do that, okay? All right, so we're going to start doing these. And so let me zoom on in so I have a little bit more room. All right, so here, so we're going to do the distance formula. So our distance formula is, at least the one I have in my head, is x2 minus x1 squared plus y2 minus y1 squared. Notice if you switch x1 and x2, you still get the same answer. Or which point is x1, which point is x2. It doesn't matter. And so some people have x1 minus x2, y1 minus y2, but since you're squaring it, it doesn't matter. So here we'll just use this distance formula, and we'll plug in these values. And so here, my x2 it will be -1, so I'll have -1 minus 5 squared plus, here I'll have -4 minus 8, so -4 minus 8 squared. Okay. So if I simplify this down, -1 plus 5 is what this becomes. So this will be -4 squared. This will be -4 minus 8. So this will be -12 squared. We'll take the square root. And you can go ahead and just use the computer from here. And I'll show you how to do that. Let me show you how to do that. So I'm going to have Wolfram Alpha up. So I'm going to do 90% of our calculations in Wolfram Alpha. Sorry, class calculator, quote unquote, while we're doing this all remotely. And it's the one I use. It's just the one I'm familiar with, right? All right, so here I'm just going to type in SQRT is how you type in square root. We forgot how to do that. We're going to do the following. So it'd be -4 squared. Oops, that's not -4, is it? -1 plus a -5, that's +4, right? +4, so don't mind me being silly. When I typed it in, it just didn't seem right. There we go. My handwriting for today's lecture, since the thing's not calibrating super well, won't be super great. I don't know if you ever worked with with a pen and a tablet where the calibration's not great, that I need to reboot the whole system to fix it. So we'll wait on that. So let's do this. So this is not -4, this is +4. Does it matter? Not really, but let's be as correct as possible. All right, so we type this in. We're going to get our two answers. So we either get 4, that's square root of 10, because this is 16 plus, this is 16. If I did it in our head, this is 16 plus 144, which gives you 160. So you can pull out the 16, which gives you 4 times 10, but this is what we really wanted. We wanted the approximate answer, so 12.649. So just write that in. So this is square root 4 of 10, or approximately 12.649. Okay. When you type it into the computer, it'll say either give the exact answer or an approximate, depending on which random question it hands you. Some of them want the exact, some want approximate. So be very careful of exactly what's in the little parentheses, how the person asks you to type it in. So just be careful about that. Okay. So we're going to find the distance between these 2 points and the midpoint for this one. So let's do that. So we're going to use the same distance formula here. So the x2 minus x1 squared plus y2 minus y1 squared. And so here, we'll go ahead and do this. And so we will have the following. Hold on. Clear something out for me. So here I'll have 7 minus a -1. So that would be +1 really squared plus 5 minus 9. So 5 minus 9 squared. So that's equal to the square root of 8 squared plus -4 squared. So this is 16 plus 16 plus 8 squared, 64. So 16 plus 64 is 90. I can't seem to do math in my head. 16 would be 70. 82? Never mind. I'm done doing math in my head. He's going to go on YouTube. It's like, here's a PhD in math. Can't do very, very simple arithmetic. 64 plus 16. Well, it's going to bug me. Let's just type it in. It should be. No, 80. Yeah, it's 80. 80 even. Hi. Yeah, it's 80. I don't even know how. Oh, man. There's a reason I'm dyslexic with numbers, and so doing some stuff in my head, sometimes I'm really good at it, some days I'm just awful. So the square root of 80, so SQRT of 80 is the exact answer. It would be 4 square root 5, because you can pull out the 16, and then you leave 5 left, and then it would be 8.944, and then since the 2, so we'll just keep it as 8.944. All right. So this would be 4 square root 5, or approximately 8.94. All right, so the midpoint is the following. So mid would be equal to x1 plus, divided by 2, comma, y1 plus y2 divided by 2. And so in our case, this will be 7 plus a negative 1 divided by 2, comma, 9 plus 5. Oops. Technically, I should have written this. Wow. Not only can I not do math, I can't speak English. Technically, it's this way. Negative 1 plus 7, and then 9 plus the 5, 2. So this gives us 6 divided by 2, so that's 3. And this gives us 14 divided by 2, so that is 7. And that makes sense. 7 is what's in between here, 3 is what's in between here. So we have 3 7s at midpoint. All right, so let's do the next one. All right, so we want to find an equation that passes through this point for both parallel and perpendicular to this line. Okay, so the first thing we want to do is find the slope of this line. So let's go ahead and do that. So we'll have minus y equals, let's move the 7 over, so it'll be minus 7x minus 8. So we move these two over, we'll divide out by the 4y, so I get negative 7, minus 7 over minus 4, x minus 8 over minus 4. So this ends up being 7/4 x plus 2. Yes. And so here we have our slope of 7/4. So the slope of this line is 7/4. All right, so we're going to do the parallel, and we're going to do the perpendicular. So for the parallel, the slope of this line will be the same as this one, so it'll be 7/4. For the perpendicular, we're going to take the opposite reciprocal, so it'll be minus 4/7. For both of these, we're going to plug it into our slope-intercept, our point-slope form. So here we have a point of y1 and x1. And so here we'll divide it between here. So in this case, here's the point we're using for both of them. So for the parallel one, we'll have minus a 3, so it'll be plus 3. So y minus a minus 3 is plus 3, equal to 7/4 of x minus 4. And we just distribute. So here we just solve because the program is going to want it in point slope form. So here we have, oops, hi, no, don't do that. Go back to the brush. Why are you on? Oh, don't make me angry. Ah, I'm back to my brush. Thank you. Now that I moved everything. Hey. I click on this. I don't know how to undo. Oh, I got an undo button. Undo. No. There we go. And we go back to the brush and make it work. Sorry about that. And so here we just distribute this. So we have y plus 3 equals 7/4 x minus 7. 7/4 times -4th will give me -7. And then here I'm going to minus 3 to both sides. Minus 3. So I get y equals 7/4 x minus 10. There we go. For this one, we're going to have the same point. So it'll still be plus 3, but m here is going to be -4/7. X, and this is still -4. Okay, so same point. We're plugging in the same point using the same formula. The difference for the perpendicular line, we're going to use the opposite reciprocal of the slope we found. Then when we do that, we have the following. So we'll have y plus 3 equals -7/4 plus 16/7. So the -4 times -4 gives a positive 16, still 7ths. And so here I'm going to minus 21/7 and then minus 21/7. So because 21/7 is 3, right? So I have y equals minus, oops, I forgot my x. Minus 4/7 x minus 5/7. Because 21 minus 16 is 5, or -5, and then it's still 7ths. And so this is the answer for the other one. Okay. I'm not sure if you should answer this. If we input the answer wrong, we should let you know. It's going to be like, yeah. So when you take these final exams, same rules apply. Whatever grade you get stands, but if you feel like you just typed in something weird or odd, just come to office hours. And I'm a lot more generous on what is allowed than the computer is. I mean, the computer is decent, but I'm a lot more generous. It's like, oh, you just rounded, kind of weird, or you put this stuff in the wrong spot. Some of you guys, the number one problem for like test 2 is like you guys put the remainder in the quotient spot and the quotient in the remainder spot. So stuff like that, and then I'll give you back points. And if your answer is close, I'll give you partial credit and stuff like that. So it's my suggestion to like plan on coming to office hours to fix stuff, because I'm happy to review the exam with you. That some of you get like 100% and don't need to do anything, or some of you just didn't know what to do, and it is what it is. So yeah, just come to office hours, and I'm happy to review anything with you and go over anything. And I never take away points, so you can only gain points. So you literally have nothing to lose. Okay, because if the program says it's correct, it's definitely correct, right? So yeah, so I'll have office hours on Thursday and Friday next week, even though I don't have to. It's just that way you guys have access to me. We can go through this, and we can get you as many points as you like before, or not as you like, but as possible, which is feasible. Okay. Okay. And for those who've been to office hours, when I give exams, could you give like a quick plug? It's like, hi, yes, this works. Because I do want people to come. I want you guys to pass. So if you come to office hours and I've helped, please do a 2-second plug in chat, because students don't believe me. They'll believe you guys. All right. I go to office hours. Pretty bad. Okay, so let's find the domain. So the domain here, so let me talk about all the domains real quick. So all the domain problems come in the following form, which we've seen. So the square root of a function that whatever is in there needs to be greater than or equal to 0, because we can have negative square roots if we're asking for that. Can we? Yeah, we would develop the imaginary numbers. But if in terms of domain, go ahead and do that. If I have some function g of x over some function f of x, so this is like the first thing you can see. The second thing you'll see is you have some fraction. That means your fraction, whatever's on the bottom, cannot equal 0, which is the case we have here. So this is the case we have here. The other domain problem, which we've seen, is we can have 1 over the square root of some function. In that case, we need to have f of x strictly greater than 0, right? And the fourth one, which we've introduced later, was the log of some function. And the log of some function, f of x, has to be greater than 0. Okay, and that will come up, I don't think today, but next time. Okay, so here, this is what we're dealing with. So here I have a polynomial over a polynomial, and so 12 minus x cannot equal 0, right? Because that's the problem we have now. Okay, so that means minus x cannot equal minus 12, or x cannot equal 12. And if you're solving for a non-equal, you solve it as if it was an equal sign, just put a non-equal sign there. It wants it in interval notation, so we're going to go from negative infinity up to 12. We do not include 12, so we use the parenthesis. And then from 12 onward to infinity. So this is all real numbers besides 12. And so this is how you type it in. Okay, I'm going to take a drink and then we'll do the next one. All right. And once again, if you ever get lost, just look at these sections, okay? All right. I do want to do 3 pages today. We may not get that far, which is fine. All right, so here we're going to be doing this. This is wrong in both this exam and your practice exam. B should be f, g of f. So I wouldn't ask you to do the same thing twice. I just forgot to switch it. So please swap this to g of f. So here we're just going to do function composition. So we're going to have f of g of x. Well, what's g of x? Well, it's right here. So we have f of x plus 4. And so here, everywhere in my f, instead of x, I'm going to plug in x plus 4. So I'll have 2x plus 4 squared plus x plus 4 minus 7. Okay. Yeah. And then from here, we'll have, remember that x plus 4 squared is really x plus 4. X plus 4. Sorry. The parallax. I think that's what it's called when between your things is bad right now. Anyway, so x plus 4 times x plus 4 would be x squared plus 4x plus 4x, so that means 8x. That would look a little bit more like an 8. Almost. 8x plus 16 plus x plus 4 minus 7. All right, distribute in the 2, so we'll get x squared plus, 16x plus 32 plus x plus 4 minus 7. And then we just clean it all up, so we'll have 2x squared plus 17x. This will be minus 3, so plus 29. Oh, I guess I did. Well, I'll go back to 5 in a second. We'll do 6 and go back to 5. Sorry about that. I just opened up the page and it was right there. So that's the next problem. All right. And notice this is a polynomial. And is the polynomial any of these ones? No. And so in this case, our domain is everything. And write everything in interval notation. It's just from negative infinity to infinity. Here we'll do this one again. So f of x, this is equal to G and F is 2x squared plus x plus 7. So we just plug where we're seeing x. We only have one x here, so it'll be 2x squared plus x plus 7. Oops, that's not plus 7, it's minus 7. Minus 7 plus 4. So the answer here is 2x squared plus x minus 3. And the domain for this is the same as before. It's just a polynomial, so it's from everything to everything. From minus infinity to infinity. All right, so let's go back to 5, see how I missed it. 5. So here, this is one of those ones where you want to say u is equal to x squared. So we'll have u's, oops, I thought that's a y, u squared minus 9u plus 20. So it's this trick where we solve a lot of quadratics by, solving something by reducing it to a quadratic. So we just do this replacement. So if you see x to the fourth minus x squared minus nothing, just make u equal to x squared. So x squared times x squared is x to the fourth. This is x squared and that. So here we can factor this, which is u minus 5, u minus 4. So notice that negative 5 and negative 4 add up, multiply to be positive 20, but add up to be 9. Now from here, we can plug back in our x. So we have x squared minus 5 is equal to 0, or x squared minus 4 is equal to 0. That means x squared equals to 5, or x squared is equal to 4. That means x is equal to plus or minus 5. We have x is equal to plus or minus square root of 4, which of course is just plus or minus 2. The way you need to type it into your computer, you'll type in minus 2 to minus square root 5. Okay, with commas in between them. All right. All right. This is just some weird formatting issue. All of this right here should be moved to right here. And so this should read, this should look more like 7 huge space if x. And I think the same formatting issue problem exists in yours. Could I show 5 again for a second? I can zoom out and then you can just see the bottom part. There you go. That you can see most of it. Okay. All right. So here, this is just find function value. So here I have a piecewise function. I just want to plug into my function these values and see what I get. All right. So if I plug in 2, 2 is between negative 2 and 4. So I'm going to be using just the 7. So this ends up being just 7. Okay. Here at 5, 5 is greater than 4. So I'm using this. So 5 plus 4. So let me just type that in. 5 plus 4 is equal to 13. Here at minus 3, I'm going to be using this. It'll be minus 3 squared plus 4. Well, that becomes 9 plus 4. This is minus 9 plus 4, so that's 5. Be very careful here. Actually, I did miss the double. Be very careful when you plug it in. That's all. And then here 4. So here it's strictly greater than, but here it's less than or equal to 4. So here, since it has the equal sign, this 4, I use this one, so it's just going to be function value of 7. Okay. All right. All right, so we want to state if it's even, odd, or neither. So let me quickly review what it means to be even, odd, or neither. So if I plug in, so here you plug in minus f of x, right? If you get back f of x, it's even. If you get back minus f of x, it's odd. And if you get anything else, it's neither. Okay. Okay, so if you plug in f of minus x and you get back the original function, it's even. If you plug in f of minus x and get negative of that function, it's odd. And if you plug in f of minus that and anything else, it's neither. So let's just do that. Go ahead and put those spacers here. So here, if we plug in f of minus x, I'm going to get 2 of minus x squared plus 4 of minus x minus 4. So if I simplify that, that'll be 2. This just becomes x squared. This becomes minus 4x. This is minus 4. So notice it's, so some signs changed, some signs didn't, and so this is neither. I spelled neither different. I spelled neither wrong here, didn't I? There we go. So this is neither. Here, I'm going to plug in minus f of x, and I get 2 of minus x cubed minus minus x to the 7th, which simplifies to 2x cubed, negative x cubed is minus x cubed, and then minus x to the 7th, negative x to the 7th is minus x to the 7th, so it'll be positive x to the 7th. And so since these signs have all swapped, I have this is equal to minus f of x, and so this is odd. And lastly here, we'll plug in f of minus x, and we get 3 of minus x to the 4th plus minus x squared plus 4. And so we'll have f of, hold on. So negative x to the 4th is just positive x to the 4th. Negative x squared is just the same thing as positive x squared and plus 4. So this is equal to f of x itself. And so this one's even. Another way of doing this, is the reason why it's called even or odd, is that notice the powers here are both odd. So both these powers are odd. This is an odd function. All the powers here are even. So 4, 2, and technically this is x to the 0 power, which makes it even. So I have 2, 4, and 0. All those are even, so this is even. But notice here I have a mixture. I have a 2, I have a 1, and technically this is x to 0, so 0. So it's 2, 1, and 0. So this is both even and odd, so it ends up being neither. Okay, so you can do it either way. I think that's supposed to be yes, you're correct, guys. Let's go back to this one. This 4 is not a 4. This 4 is an 8. Which gives you 13. Where did I get 4 from? Thank you. Sorry about that. Oh, I got it from, I must have, I don't know, my brain must have just pulled it from there. Oh boy. Sorry about that. Okay, any questions from this page? Why something's even or odd, following function values, and all this. Okay. All right. All right, so let's do the next. Let's see. Technically, class is over in 2 minutes. Do you want to finish this page, or you want to just do 4 pages next time? It's up to you guys. Because technically, Tuesday, Thursday is the shorter class, and Monday, Wednesday is the longer class. Just finish this page. All right, so let's do half and half. Okay. If you need to go, I'll post it online. So here we want to solve this for C. So let's solve this for C. So what I would do, what I personally would do, is just multiply both sides by C. So I'm just going to multiply by C, right? So be careful what you're solving for. Here, these C's cancel, so I get CH over PJ equals Y over M. Or you can just move the C out, whatever makes sense in your brain. Then from here, I'm going to multiply by the reciprocal of everything here. So I'm going to have P and J over H, and multiply by P and J over H to both sides. So I'm multiplying, basically I'm dividing by everything, which is the same thing as multiplying by the reciprocal, because this PJ crosses off this PJ, H crosses off H, and so I have C equals Y, PJ over and H. Okay. So this is just one of those things. Can you manipulate this one? Here, on this one, we're going to just type this into the quadratic formula. You just don't solve it. So here we get 3x squared plus, oh, no. Let's move it all to one side. So it'll be minus 5x plus 5 is equal to 0. We're going to type that into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in our case, so b, so this is our b, this is our a, this is our c, so a, b, c. So minus b would actually just be positive 5 plus or minus negative 5 squared, which is 25, minus 4 times 3, which is 12, times 5, which is 60. So it'd be minus 60 all over 2 times 3, which is 6. This simplifies down to 5 plus or minus 35, or negative 35, sorry, over 6. And then from here, we pull out the I. So it'd be positive 35, or I, positive 30, square root of 35 over 6. And then the way your book wants you to write it in would be 5 over 6 plus square root I square root 35 over 6, comma, 5, 6 minus I square root 35 over 6. So that's how you type it in. If you're wondering how to type it into Wolfram Alpha, I'm pretty sure I did it today. Yes, there it is. All right, so here, if we want to type in Wolfram Alpha, you just type in solve, and then you just type in the original thing, and then it crunches through the result. Notice our result matches the one here, right? Matches one here. You can use the solve to solve for anything. And so let's say we had the H divided by PJ equals Y divided by C over M. And we're going to say, actually, in this case, you can say solve for C. I wonder if it's this smart. Nope, it's not that smart. We're going to have to put in little multiplication signs. Hi. See if it's smart now. G. Oh, here it is. I type it in wrong. Why does it have it upside down compared to what I have it? That's going to bug me for a second. I have no clue why. I wouldn't do this because apparently this isn't doing it all that right. Yeah, I wouldn't do it for this. That's terrible. I was hoping to be useful. It's not. It's just not. Because that's not the right answer. So, well, it was worth a try. It was worth a try. Don't type it in. Apparently it doesn't work. And it's good to know it doesn't work. That way you guys don't try it. All right. Let's do this one. All right, so we're going to solve this. We want to write a solution interval and then graph that one. And so here, remember, so from section 3.5, if I have it less than, I just type in -8 greater than, or -8 is less than 2x plus 2, which is less than 8. So you just take the absolute value and just split it this way. If it's the other way, you just, it's the other way, just real quick, I won't actually solve it. I'll erase it after I write it. So it'd be, say it was -2 pretend we got this problem instead. Oh, actually, let me just write it as a completely different problem so you don't get confused. Is greater than 4. Yeah, let's give us 7, though we have different numbers. If it's this, remember you just say we have 3x plus 4 greater than 7, and that looks like a 7. We have 3x plus, come on, 4 less than minus 7. So remember you just swap it this way. Okay, but that's not what we're doing. We're doing this one. So I'll go ahead and erase this 5 room to do everything I want to do. Remember all this is bounded 3.5. So here I'm just going to add 2 or minus 2 everywhere. So I get minus 10, 2x, 6 divided by the 2. So I get minus 5, x, 3. And then when I graph it, I'm just going to find the minus 5. I'm going to find the minus 3. Put a little parenthesis right here. Put a little parenthesis right here. And it's everything in between. Okay. All right. And then let's do this last one. So here, remember for this one, we're going to find our least common denominator. And so here, we're going to have an x plus 4. Here, we need an x minus 4. And notice here that x squared minus 16 is equal to x plus 4, x minus 4. It's a difference of squares. And so this one has the x plus 4 and the x minus 4, so we don't need to add it. Okay? So we're going to just multiply that to both sides. So here we're going to have x minus 4, x plus 4, multiplied by 4 over x plus 4, plus 1 over x minus 4 equals 13 over x squared. 16 times x minus 4, x plus 4. Okay. And so here we'll get 4. This x plus 4 cancels this x plus 4, so we have 4x minus 4. Then this x minus 4 cancels this x plus 4, so I'll have 1 plus x plus 4. And then x squared minus 16 is the same thing as x plus 4, so these two cancel, so I'm just left with 13. Another way of doing it is the way I taught you. It says once you get your least common denominator, just multiply what's on top by everything which isn't on the bottom. So 4, there's an x plus 4 on the bottom, but there isn't an x minus 4, so 4 with that. There's a 1, there's an x minus 4, but it's not an x plus 4. So we do that. And here we have both, so it's just the 13. Either way, you get to this answer, okay? Then from here, I have 4x minus 16 plus x plus 4 is 13. That means it gives me 5x minus 12 gives me 13. That gives me x. Or 5x minus 25. I mean, x equals to 5. Okay. And we can just check that really quick. Let's just type this one in. This one should work. Oh, I know why this didn't work. Why didn't this work, guys? Because it didn't get inputted correctly. Hi. Ta-da. So they're being silly. This looks correct, and it gives the correct answer. Ooh. Yeah, you can use this. It works fine. I just didn't type it in right. Be careful how you type stuff in. Sorry about that. I looked at that and was like, no, it can do that. I did it wrong. I typed it in wrong. All right, what are we trying to solve here? Yes, so it would be 4 divided by, was it x plus 4 on the first one? Yes, x plus 4. Plus 1 divided by x minus 4 equals 13 divided by x squared minus 16. There we go. And we get x equals 5, which is what we got. Okay. All right, so here's the 3 notes. And so here we want to find the vertex. So we are just going to use this formula here. So x is equal to minus b over 2a. And then so that's the x, the y, and the y is just you just plug in that function value. And if a is greater than 0, it'll be a minimum value. And if a is less than 0, it's the maximum value. Okay, it's basically if it's a positive or a negative. So let's do that. And so here we have a to be positive. So here we'll have x is equal to minus b over 2a. Zoom on in a little bit. And so minus b over 2a. Something seems different when I'm drawing, but that's fine. And so in this case, it'll be positive 10 over 2 of 1. It's like my pressure is on for some reason. Why is my pressure on? My pressure shouldn't be on. I just hard round. There we go. And so here, this just becomes 5. So here we have 5 as our, so 5 is our vertex. And then here we'll go ahead and plug that in. So it'd be, so f of 5 will give us our y value. So it'd be 5 squared minus 10 times 5 plus 21. So we get 25 minus 50. So it'll be minus 25 minus 50. So that's negative 25 plus 21, so it'll be minus 4. So we get a vertex of 5 and 4. And so that's our minimum value. We want to graph the function. You'll use the graphing, whatever it is in Pearson, but let's just graph it in Desmos real quick, just to make sure it looks like what we expect it to look like. And it's a great way to check our vertex. Make sure we did everything correctly, because I do things wrong from time to time, as we all know. All right, so here we have a vertex at 5 minus 4. Okay, so that's the correct vertex. It opens upwards, right? The minimum, the axis of symmetry would be x equals 5, right? Our minimum value is y equals negative 4, and it's a minimum since this opens up like this. And to graph this, what I would do is I'd usually just graph this point and just find one other point, right? Plug in 6, and then you'll probably get the value of minus 3, right? So if you plug in 6, you get the value of minus 3, and just so you click that and you click the other point, and then Pearson graphs it for you. So that's how you do this one. Isn't it? Yeah, no attendance for the last 2 days. All right, so let's do the next one. So here, this next one here. Here we want to take x plus 4. So here we're going to get the radical on one side and everything else on the other. So that'll be x minus 2 at this point. Then we're going to square both sides. So we'll have x plus 4 equals, and then we'll square this, so it'll be x squared minus 4x plus 4. Because remember, x minus 2 squared is equal to x minus 2, x minus 2. And so when we do this, it'll be x times x gives me x squared, minus 2x, so it's minus 4x, and then negative 2 times negative 2 gives us positive 4. Move everything to one side, so we'll just move it all this way. So I have 0 equals x squared minus 5x. And that's it for here, right? Then we can just say the factor of this is actually really quite simple. It's just x minus 5. So that gives us the values of x equal to 0 and x equal to 5. So let's test the two values. So here if I plug in 5, but remember you have to test them. So we have to check both values. So here we're checking both values. So we'll start with 0. So 0 plus 4 square root plus 2 equals 0? And that answer is no, right? Because this is 2 plus 2, so 4 does not equal 0. And so this is an invalid answer. We'll check the 5. And so we'll have square root 5 plus 4. So square root of 5 plus 4 plus 2 is equal to 5. And so here, this gives us 9. So this would be 3 plus 2 equals to 5. And so this works out. So the only answer here is 5. So remember when we solve radical equations, we need to check the answers. Okay. What was the minimum value? Oh, so let me go back up to here. So the minimum value, so it has a minimum, since this a is positive, right, of y equal to minus 4. Okay. And the axis, if it asks for the axis of symmetry, that's going to be x equal to 5. Okay. All right. So that's how you do this one. For this one, it's just order of operation. So here I'm going to do 3. I'm going to move in the minus 2. So I'm going to have minus 18
It's just me.
x minus 8 equals 9x plus 9. Here we'll just collect all the like terms. So I'll move all the x's to one side, all the positives to another. So I'll have, this becomes minus, so this minus 18x minus 5 equals 9x plus 9. Move that over, so I'll get 21x, and then move this over, so it'll be minus 14. And so here I'll get x is equal to negative 14 over 21, which simplifies to 2/3. And then we'll check it. Let me just double check everything. I don't trust my brain today, which is fine. You'll be stressed out when you do yours, and you can double check yours. So let's just check this in Wolfram Alpha. Yeah, leave the page. Let's go to Wolfram Alpha. So here, we just want to check this. And can I copy and paste? Nope, that'd be asking too much. Far too much. All right, so let's just do this. So you just type in solve, and then you type in this. So it'll be 3 minus 2 times 9 x plus 4 equals 9 x plus 1. I kind of hope I do mess up something so I can kind of show you how to figure out what you did wrong. But at the same time, no one wants to mess up, so I kind of hope I didn't. 1927. Oh, see? What did I do wrong? Is this 21? No, it's 27. That's just arithmetic problems. See? And this is why you check your answer. So 1427, this doesn't, and this and that doesn't simplify. Okay. Minus 18 plus 9 is 27, not 21. So there's your final answer. And you just type it in as a fraction. All right. For number 16, we're going to be using synthetic division. So synthetic division, where is that at? Hi, computer. Why are you... a bit chunky, so let me just clear off some of these things real quick. All right, so let's open. So let me open up what we're doing. So where's my synthetic division notes? That is 4.3. All right. So you should always have your completed notes somewhere on you, right? And so here we're going to be doing synthetic division to do this. So remember, synthetic division is x minus c, right? And you just do this algorithm here. And so we're going to do that right here. And so here, so our minus c would be minus 4. So we're going to put our minus 4 in this little box here. So we have a 4. We have a 17. We do not have an x squared, so we put in a 0. We have a minus 1 and an 18. Anyone confused on this step right here? Let's see. Nope. Okay, so we're going to go forward. So here we just drop down the 4, so we get a 4. 4 times minus 4 will give us minus 16. Drop that down, we get a 1. 1 times negative 4 is minus 4. Add that up, I get minus 4. Minus 4 times minus 4 gives us positive 16, which gives us 15. And then 15 times negative 4 gives me minus 60. 18 times minus 60. See if I can do math yet today. Should be 42. Minus 42. Yes. Okay. And so here we're just going to write out, so the quotients first, and so we're going to just write this out. Remember, it's x is 0, x. So here's the first one's our constant term. This is our x. This is our x squared. This is our x cubed. So here our quotient would be 4x cubed plus x squared minus 4x plus 15. And our remainder, r of x, q of x, sorry, r of x should be minus 42. Okay, and so let's just check this in Wolfram Alpha. It'd be good to know how to check all your answers, so I'm happy to actually double check everything with you. So here we're just going to do this division. 4x to the 4th plus 17x cubed minus x plus 18 divided by, I have an e here for some reason. Just hit enter. Oh. Here we go. Here we get what we want. Here we have the quotient remainder. So here's our quotient. So we got 4x squared plus x squared minus 4x plus 15. So we got that correct. And we have the minus 42. So here's the two answers right here in the quotient remainder. Okay. All right, so let's go to the next page. I'm actually going to take a drink as you guys write it down. All right, so here we're going to do solve this inequality. And so this is 4.6. So if you want to open up the 4.6 notes, you're welcome to do it. So what we're going to do here is we get everything to one side. And then we're going to solve, we're going to factor this. So this will factor into x minus 2, x minus 5 is less than or equal to 10 or 0. Okay, so once we do this, we draw in our little number line. We're going to put in 2 and 5. So positive 2 and positive 5 are my zeros, right? And so we're just going to test some points. So we're going to test the point of 0. We're going to do 6, and we're going to do, oh, I don't know. Oh, no, 0's here. I can't test 0. That's not between these two. I'll be on the right layer. So let's test, I don't know, 3, 6, and 0. And we just want to know what sign it is. So if I plug 0 into here, I get a negative number. I get a negative number, so this becomes a positive number. So this is positive. Here, if I plug in a 3, this is a positive number. This is a negative number, so this one's negative. And then if I plug in 6, this is positive. This is positive, so this is positive. Okay. All right, so what's the answer here? Well, it's less than or equal to, so I want the negative, and since it's equal, I'm going to include the points of 2 and 5, and so it's going to be 2 comma 5. So there's my answer, right? And to write it in interval notation, there it is, right? And so we use the brackets since we include them. And the way to double check this is you just type it into, in my opinion, the easiest way to double check this is just to type it in Desmos real quick. So let's go back to Desmos. And we type it in. So we have x. So just type it in with the equal sign. And notice if I want everything that is less than 0, in this case, it goes from 2 to 5, and that's everything down here. And so here we check what we got. Okay. All right. Let's go to the next one. So here we have some log function. I put in log base 10 to make it very clear that we're just doing log 10. Your book's just going to write log, which is fine. So your book will look like this when you take it. And so when we do this, the first thing you want to do is combine the log functions. And so we're going to have log of x times x minus 9. So you multiply, so the addition turns into multiplication. So we have a single log on one side and everything else on the other. Then we're going to exponentiate both sides by 10. So the log of 10 of base 10 cancels this. So this is x times x minus 9 equal to 10 to the first power is just 10. And then here we just solve for it. So we're moving the x, so we have x squared minus 9x. Move the 10 over, minus 10 equal to 0. And I don't know if this factors all that nicely from here. It may not. No. Oh yeah, it does. X minus 1, x plus 10. There it goes. Yeah, factor's fine, right? Oops, I have that backwards. It's x plus 1, x minus 10. So let me shut that door real quick. All right, so now what do we do? Well, what does this equal 0? Well, this is, so we get the values of x equal to -1, and we get the values of x equal to 10. So let's plug them in, because remember, you do have to check these. So we just have to check that we have no negative log. So if I plug in -1, I get a negative log here, so this one doesn't work. But if I plug in 10, this is positive, and this is positive, so that works. Okay. All right, so let's check this in Wolfram Alpha. All right, so we're going to type in log. Remember, Wolfram Alpha thinks log of nothing is log base c, so we're going to log base 10 of x. So always type in log base 10 in Wolfram Alpha, just to be careful about it. If not, you'll get wrong answers. X minus 9 equals 1. All right, crunch it through. And here you see our solution is indeed 10. Okay, so that's just a way of checking. All right, so now let's do the inverse. So this is 5.1. Let's find our inverse here. So here we're finding the inverse. And determine if it's 1 to 1. 1 to 1 just means it a unique input has a unique output. The best way to do that is just to type it into Desmos. So let's type it into Desmos. Desmos. And we just type in the quantity of x plus 6 divided by the quantity of x minus 5. And we just look at this real quick, and we notice that here it passes the horizontal line test. And so if it passes the horizontal line test, it is 1 to 1. So this one's 1 to 1. Let's open up. Let me open up the notes real quick. So this one says it's 5-1. So if you go to the 5-1 notes, wherever I put them. Current classes, this one, the type notes. Let's open up 5.1. Notice here how to find the inverse of a one-to-one function. We're going to just follow these steps. We're going to write y is equal to this, interchange, solve, and then write this. So we're going to do these steps. So please have your completed notes somewhere with you, just in case you forget what to do. So the first thing we want to do is write y equals x plus 6, x minus 5. We're going to swap, so that's the first step. The second step is to swap the x's and y. So we have x equals y plus 6 over y plus, or y minus 5, sorry. The third step is to solve for y. And so we'll just move that over. So we'll have x of y minus 5 equals y plus 6. And so this is xy minus 5x equals y plus 6. We're going to move the y's over. So I'll have xy minus y equals minus 5x plus 6. Factor out the x. I'll have x. No, factor out the y. I'll have y of x minus 1 equals minus 5x plus 6. So y equals minus 5x plus 6 over x plus 1, or x minus 1, sorry. And the last thing we do is write it as f function inverse is minus f of x plus 6 over x minus 1. All right, and then what we do, we check it. I'm going to check it into Wolfram Alpha. Wolfram Alpha. I'll go ahead and leave the page. And so here we just type in the inverse function. No, not inverse Laplace. That's definitely what you guys aren't doing. Inverse function of x plus minus 5. Is that what it was? And then you just let it crunch through, and ta-da! Yep. And did I make an error? Oh, you betcha I did, right? When I moved this over, this should have become positive, right? So double check your answers. I missed the negative sign. Sorry about that. Yeah, and so here we check our answer, and so it's positive 5x. Remember when I moved it over here, apparently I forgot to swap the sign. So be careful with negatives. I mess them up too. And there we go. All right. All right, so let's do the next one. So here we have two different exponentials. So I just take the log of both sides. So we'll take ln of 6x equals to ln of 2x plus 1. Then by the properties of log, you can pull out the x. So ln of 6 is equal to ln of, ln of 2. We'll go ahead and distribute. So I have ln of 6 equals ln of 2, or x ln of 2 plus ln of 2. Move all the x's to one side, so I have ln of 6 minus x ln of 2 equals ln of 2. Factor out the x. Ln of 6 minus ln of 2 equals ln of 2. And then just divide out, so I have x is equal to ln of 6 minus ln of 2 all over ln of 2. And there you go. And so this is the answer. And then you just, and then you can approximate it in Wolfram Alpha. And so we'll just type in, so we'll type in ln of 6 minus ln 2, because I think you type it into 3 decimal places. Do whatever it tells you to do. Yeah, and so here we get this decimal approximation, so 1.5159, and this will round up to 5. So let me put that in. So it's 1.585, the way it rounds. And then here, if you want to check it, you can also say solve x, or 6 to the x equals 2 to the x plus 1. Is that what we had? Is it x plus 1 or x minus? Yep, x plus 1. Crunch, 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 crunch. Okay, approximate form. Either I typed it in wrong or I did something wrong. Let's find out what I did wrong. Did I type this one in wrong? Yes, I did. What did I type in wrong? I typed it in backwards. Is it ln of... If I divide... No, I just divided absolutely wrong. Hi, guys. Does anyone notice what I did horribly wrong? You should. If I divide this from this, I should get ln of 2. Oh, man. L6 minus ln of 2. This is completely different. Yeah, I was confused. Thank you. You should have said something. So here we get the same thing what we typed in before. So it should be 0.0. So 0.631. This is why you check your answers. And then now, if I go back to, oops, where'd it go? I typed it in, history. There it is. Whoop. Now when I type this in, I should get the same answer. Keyword should. Yes, so now we have the same answer. All right, sorry about that. So just go ahead and do this, and you get in. So you can type it in. Do it by hand. See what you get. Type it in, and make sure those both match, because you can easily make mistakes in either. All right, let me take a drink, and then we'll do the last page. And so we have just these 5 problems to go. Oh, okay. Boop, boop, boop. All right, so here make up 2 functions, no equations, and statement intervals, they're decreasing, increasing. So here I just want you to make up some stuff and get used to just... And so this is the one where the book almost always looks like this or something. Where this is like at 1, this is at -2, this is at like -4, this is at -6, and this is like a -5 or something. And so here, and just want to say where it's increasing or decreasing. So here it's increasing from -infinity to -5. And it's also increasing from like that, look like a 2, from -2. I think your book wants commas, -2 to (1). So this is where it's increasing. It's decreasing only between 5 and it's decreasing only from -5 to -4. Remember, always use parentheses. It's not increasing and decreasing at this point, or at this point, or at this point. And then it's constant. It's constant between -4 and 2, so -4 and 2, and from 1 to infinity, comma 1 to infinity. Okay. All right. And so this is the type of problem that one's addressing. We can do another one real quick. We can just do something kind of goes down, goes up, is constant, and then goes down for infinity. Let's just do this one. So here, where is it decreasing? Well, it's decreasing from minus, let's make this minus 3. Let's make this 1. Let's make this 4. Okay. So here it's decreasing from minus infinity to minus 3. And from 4, comma 4 to infinity. It's increasing between negative 3 and 1. So it's increasing from minus 3 to 1. Keyword should, right? And then it's constant, and then it's constant between 1 and 4. Okay, so for these, just make up any two. These are just two I made up. All right, now let me draw and we'll get some clear space. All right, so when you see something like this, this is just a radical equation. So we're going to just multiply everything by y. Why? Because that clears out my fraction. So if I multiply everything by y, I get y squared plus 4 equals minus 5y. Then I just solve for y, so I get y squared plus 5y plus 4 equals to 0. And then here I can solve y plus 1, y plus 4. Oops. Is equal to 0. That means y equals minus 1 or minus 4. And how do we check this? We just type it in wolf from alpha. Wolf from alpha. Wow. Let's see. So we have y plus 4 divided by y equals minus 5. So it crunches. It's thinking hard. Yeah, and so here we get negative 1 minus 4. Okay, so here you just multiply by y or t or whatever variable it has to clear out the fraction. And then it just turns into a normal quadratic. Okay. All right. The next one here is use elimination to solve the system of equation. Identify if it's consistent, inconsistent, and all that other stuff. We'll get into that. So let's do this. And so here, I'm going to call this equation 1, call this equation 2. I'm going to do elimination, so I'm going to do 3 times, 3 times equation 1, and then just have equation 2. And so that'll be 15x plus 3y minus 36. And then we'll have 7x minus 3y equals minus 30. So we add these two up, we'll get 21x equals minus 66. Gee, is it that awful a number? It could be. Hold on, I don't check my math because I don't expect it to be that awful, but it might be. Multiply by 3, so yes, 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 yes. Add this up, I get 20. Hold on, that's not 20. I want to make everything 21 today when it's not. It's 22, thank you. It's still a pretty bad number. Oh no, I guess it's not at all. Equals minus 66. Yeah, and then when I divide this out, I just get a boring minus 3, right? X is minus 3. Pretty boring. Then I'm going to just plug that into equation 1. And here we'll have 5x plus, oh, but we know what x is, so it's 5 times minus 3 plus y equals negative 12. So I have minus 15 plus y equals minus 12. So y equals 3. And so my solution set should be 3, negative 3, 3. And since we have a single solution, it is consistent. We have a solution, so it is consistent. And since we have a single solution, it's independent. Independent. Okay. So it's consistent and dependent. Or independent, sorry. Yes. Now what do? We just type this into Wolfram Alpha. We just type system equation just to double check ourselves because we've seen how lucky I've been for solving these things. Just type in system of system two equations. Perfect. Thinking. It's thinking hard. Oh, here we go. So our first equation is 5x plus y equals -12. Our second equation here is 7x minus 3y equals -30. Compute button. And we wait for a hot minute. Either my internet's super slow or, yeah, so we get -3 and 3, right? And that's the answer we got. I can see 21 again. I don't know why I have 21 in my head. Maybe it's time for me to go play blackjack or something. Anyways. All right, so here we're going to be doing the difference quotient. So this is find the difference quotient or evaluate this. This is the difference quotient. Sadly, I say MathWay does check this for you. I can check it faster in my head using a different method, but we'll skip that because that uses calculus. And so what we're going to do here, we're going to plug in f plus h minus f of x minus h. So let's do this really slowly. So f of x plus h would be 2x plus h squared plus 5x plus h. That look more like an h, I suppose. H minus 7 minus the quantity of 2 of x, f of x. So here we'll just plug in f of x right here. All divided by h. The next thing we want to do is expand this out. So it'll be 2x squared plus 4x xh. Because notice here, when let me write this over here real quick, x plus h squared is equal to x squared plus 2xh plus h squared. And so when I multiply by 2, I'll get 2x squared plus 4hx plus 2h squared plus 5x minus, or plus 5h. Just distribute that. H minus 7, distribute this negative, so it'll be minus 2, so minus 2x squared minus 5x plus 7, all divided by h. And if you did this correctly, this should cancel this. A lot of the things should cancel. This cancels this. This cancels this. And so you should be left with things only in h. So I have 4xh plus 2h squared plus 5h, all divided by h. So you can factor out an h up top. So we'll have an h times 4x plus 2h plus 5 all over h. Sorry, someone's doing yard work. It's just not my day. That's fine. And so we get our final answer of 4x plus 2h plus 5. Okay. Now can we check this? Sure. And so here we can just type all this into Wolfram Alpha. So we'll just type in, so we'll have the, I don't even know if this thing does difference. Oh, it does different quotient. Whoop. Can we just type it in? Is it just that smart? I'm super curious. We'll see if it can do it. I'll let it crunch on the side as we answer our last question. Oh, look at that. Look at that. You just type in difference quotient and this, and presto, you pop out the right answers. Wolfram Alpha can seriously solve all your problems, or at least all your math problems. not sure I can type in the rest of the stuff in my life in Wolfram Alpha. All right, so let's do the very last one. And this is a word problem. And so it says, Kirk can be paid one of two ways for furniture sales. So either he can make a salary of, so he can make a salary of $900 and 10% of his sales, or a salary of $1,200, and 15% of his sales in excess of $800. At what plan is plan B better than plan A, assuming Kurt sells more than 9? Oops, that should probably still say 8,000. Okay. These two numbers should match. So let's figure it out. So plan A is I want to have, so you get 900 plus 0.1, so 10% of his sales. And we're going to write his sales as X, and I want to know when that is less than plan B. So this is my plan A, and this is my plan B. And so plan B would be $1,200 plus 0.15 of X minus 8,000, okay? Because it's sales he makes in over $8,000. So we have this inequality, so we just solve this inequality. So let's go ahead and do that. So we're going to distribute over. So we have that, and then this becomes 1,200 plus 0.15x, and then 1.5 of 8,000, which I do not know, so we'll just type it in because my ability to do mental math today has been 0. 0.15 of 8,000. That's 1,200. All right, so that's 1,200. That's 1,200. So this number conveniently cancels this number. So I have 900 plus 0.1x is less than 0.1x. So we minus 0.1x from both sides. And so we have 900 is less than 0.05x. We take the 9, and then we're just going to divide by 0.05 to finish this. And I should, oh good, I have room. So x is 900 divided by 0.05. It's the same thing as multiplying by 20. So 18,000. So here x is greater than 18,000. And so the answer here is what's the amount of sell he needs to sell over 18,000. Okay. So to set this up, you just write plan A. So plan A is he makes $900 of his sales, right? Plus 10% of the sales after that. And here he makes 1,200 plus 15% of sales over 8,000. So this is plan B. You just write this, you solve the inequality. I'm pretty sure once you write it out, I'm pretty sure this will just solve it for you. So let's just go ahead and type it in. So you just type in plan A, which is here. The plus 0.1x is less than the 1,200 plus 15% of our sales minus 8,000, because I have to get over 8,000. Crunch this through, see if we get the same number. Yes, we do, right? X is greater than 1,800. All right. So that's the end of that, and that's how we type them